Hi everyone, I'm Matt Skywalker. Today for this video, I'm going to discuss about the indices and logarithm. This is taken from the additional mathematics from the SPM syllabus. So today in this video, I'm going to explain what the student must know and what things they must master under this topic, which is indices and logarithm. Okey, untuk bahagian pertama di bawah tajuk indices and logarithm, kita pergi kepada indices and law of indices, which is the first one is we are talking about integer indices. Okey, sekarang untuk positive index, okay, A is we assume that this is a non-zero number when A is multiplying by itself n times is denoted by A to the power of n, where A is not equal to 0 and n is positive integer, such that here is the illustration. A multiply A and then so on until the last A. So we assume that the number of A we multiply here is n. So A to the power of n. For example, A to the power of 3. Here we have A times A times A. So we have A to the power of 3. We have 3A here. Next, we are going to zero index. What is the zero index? Okay, by law of indices, A to the power of n divided by A to the power of n is equal to 1, where A is not equal to 0. Because if A is equal to 0, this here we cannot get 1. Okay, and then this form we can turn to this form. A to the power of n divided by A to the power of n, we also can write it as A to the power of n minus n, which is equal to 1. Same here. But n minus n, since n is a number, so we have 0 here. By definition, we know anything is power to 0 is equal to 1, where A is not equal to 0. Okay, now we go to negative index. A to the power of negative n is equal to 1 over A to the power of n. This is by the definition also. Okay, these three things, before we go more further in this topic, we must know these three types of index, which is positive, zero, and negative index. Next, we are going to fractional indices, which is the first one. A to the power of 1 over n is a positive nth root of A, which means that A to the power of 1 over n is square n root A, not a square root. I'm sorry for that. Okay, again. A to the power of 1 over n is a positive n root of A. Okay, for example, square root of 4 is 2. Now we have A to the power of 1 over n is n root of A, where A not equal to 0. For example, we replace A with 4, n with 2, so we have square root of 4. So we will get 2. That one is the example. Okay, now we go to number 2. A to the power of m over n is the m power on n root of a, or the n root of a to the power of m. Here we have a to the power of m over n is equal to m is equal to n root of a to the power of m, also equal to n root of a to the power of m. You know what I mean? Here is m power on n root of a. This one is n root of a to the power of m. This is equal. All this is equal. Okay, next we go to the laws of indices. For all real numbers a, m, and n, a to the power of m times a to the power of n is equal to a m plus n. And then a to the power of m divided by a to the power of n is equal to a m minus n. Remember the negative index that we have discussed before, where a to the power of n divided by a to the power of n is equal to 1. How we can get that? Because a to the power of n minus n is a to the power of 0. That's why a to the power of 0 is equal to 1 from the negative index from the previous topic. Okay, here we have a to the power of m, and then overall here to the power of n. Then we get a to the power of mn. Okay, next what we need to know under this topic is how to convert the equation in index form to logarithm form, or vice versa. For example, we have the inverse function of y equal to a to the power of x is y equal to log x to the base a, where a is greater than 0 and a not equal to 1. Okay, graph below shows the relationship between y equal to a to the power of x and y logarithm x to the base a. This is the y equal to a to the power of x, and here is y equal to logarithm x to the base a. X, y, 0. This is a symmetric. Show that this curve is inverse. The relationship is between this curve is inverse. This one is the inverse of this one. This one is the inverse of this one. In general, n equal to a to the power of x if and only if log n to the base a is equal to x. Here we get by we multiply the log to the base a on the both side, log to the base a n and log to the base a here, a to the power of x. So we will get log to the base, log a to the base a is equal to 1. X we put in front. This one you need to imagine first lah. When we put log a to the base a here, then x we can bring front. So log a to the base a will get 1. That's why we have only x here. And then n, we put log n to the base a. That's why nothing to be cancelled out. So we just left log n to the base a equal to x, where a greater than 0 and a not equal to 1. Okay, next we are continue how to find the logarithm of a number. Okay, for example, now we have log x to the base 10 is a logarithm to the base 10, known as common logarithm. This can be obtained from scientific calculator. For example, the value of log 25 to the power of 10, we can just press the log from the scientific calculator and 25. So we will get the value from the calculator. And then this is the way we can write in the exam. So the candidate must know how to write this thing. But this one is only applicable for base 10. Okay, log x to the base 10 also can be written as log x. Also can be written as LGX. The examiners will understand that this log x and LGX is log x to the base 10. This is the way we write. Just the way we write. Okay. Next, we go to the laws of logarithm. Okay, log x times y to the base a is equal to log x to the base a plus log y to the base a. Remember, when x times y, when multiply, we will have plus here. Next, log x divided by y to the base a, so we have log x to the base a minus log y to the base a. Here we must remember, when we divide, we will have minus here, x divided by y, so x log x to the base a minus log y to the base a. Here we have log x to the power of q to the base a, so we can bring q to in front and left log x to the base a. And then the last one, the things that you must know under this topic, indices and logarithm, is how to change the base of logarithm from base a to c. For example, given log b to the base a, now we want to change to the base c. So we will have log c, new base. We take this one, log b to the base c, log a to the base c. So here we have the new base lah. When c is equal to b, how? Okay, just write in this form first. Then you will notice that c is equal to b. When you replace b, when you replace c by b, you will get log b to the base b. Then we will have 1. Then log a to the base b. So this thing will equal to 1 over log a to the base b. That's all. You must remember this, how to change the base. And then this one is the kind of example when the situation is c is equal to b. That's all. I hope my video can help you to get at least basic understand what is indices and logarithm, what is actually happen. Any question you can ask in the comment. Good luck.